Okay, so in this video, we are going to discuss about bond amortization schedule. So this is very similar what you learn in the loan amortization schedule. When I go through this, you will see that the concepts are actually very similar. Okay, so the purchaser of the bond can be thought of as the lender. Okay, so we have bond buyer as the lender. Okay, because at very beginning, the bond buyer would pay to buy the bond, and then at the end, even middle, you will get some coupon amount, but at the end, you will get the redemption amount. And the issuer as the borrower. So the bond issuer, so let's say gamma is going to be the borrower. The purchase price of the bond is P, can be thought of as the initial loan amount. Okay, so the price P paid by the buyer. Okay, so P paid to issuer. So this can be thought of as the initial loan amount. And the coupon amount and redemption amount, and the coupon amount and redemption amount payment are the loan payment made by the borrower. So you have this. So if I draw the timeline, so here I have 0, here is P, which is the price. Basically, issuer is borrowing from us if we are the buyers. So that would be the initial loan amount. And then after that, you will have this coupon payment. Let's say coupon payment FR plus C. Okay, so we can view bond and its periodic coupon similar loan with periodic loan payment. We can construct a schedule where each coupon paid is considered to be a combination of interest received and principal return. For taxation and other accounting purpose, it may be necessary to recreate amortization schedule on bonds you own. Why is that? We are not going to go to the taxation because it's not actually part of our syllabus or part of actuarial science. Taxation is, you have to be careful because the interest received need to be taxed under a different tax regime. So when you get the payment, if you just tax the entire payment, then you may have to pay a lot. But if you break into interest received plus principal, so you get the payment. So this would be interest received plus principal return. And this would be the additional gain for the one who's receiving the payment, in this case buyer. So then this can be taxed. Okay. So instead of like taxing entire payment, now you are really taxing portion of it. So in order to do that, you have to really break down the payment into two components. So that's why we create this kind of amortization schedule. So for the taxation purpose. Okay. So in here, you can see that the interest received for bonds are often subject to income tax. Okay. By the way, the state we are in, Tennessee, they don't have state income tax. Okay, so no state income tax for Tennessee. Even though taxation and bonds are not covered in exam FM, you should read following article to get general idea. Okay, so please read this. These are not really comprehensive articles like which cover each and everything about taxation. It just has a little bit idea. So spend few hours on these articles and read it. So now we go to the bond payments and see how we are going to divide it to the interest plus principal amount. Okay. So we define the book value to be present value of all future payment. This is actually what we use in the loan payment. So if you remember the prospective approach, in there the book value or the outstanding loan balance. This is from the loan payment model, okay? We define as present value of all future payment. Okay. There's another way to get this. It's called the retrospective. If you don't remember the approach, please check the loan payment module. Under retrospective approach, you would take the future value of, the current value of all past payment, and then subtract the current value of the original loan amount. Okay. So just check the retrospective. But in here, we are using the prospective. Basically, present value of all future payment. So we let BT to be the book value. So now on the bond, we just call it as book value, not the outstanding loan balance. Okay, so this is, we are not going to use this. We would call it as book value. So what's the book value? Book value is basically present value of all future payment. Okay. So if I have a bond at time 0, let's say P, we have let's say N coupon. So you are paying coupon amount FR. Then I are standing here. So so you want to know the remaining the present value of all future coupon payments. So you would write BT at this time point is present value of all future. So we are thinking about only this. Okay, so this one is not going to include. Okay, so this not included for this calculation. Okay, so present value of all future payment. Oh, by the way, I needed the redemption amount here. Okay. So that would be FR. And then this is annuity. You can see start from T plus 1 to N. So how many are there? There are N minus T. And it's annuity immediate. Plus the time difference between here is N minus T. So see N minus T. So that's what you see in here, the initial formula. Now, this one, if you remember the premium discount formula, you can write it as C time G minus J A N minus T J plus C. Okay. Remember the premium discount formula, it's P equal C times G minus J A N actually, when you have N, we wrote N plus C, then we take C to this side, and we call P minus C equals C N, and this is the difference between price and the redemption amount, which we call as premium discount. Okay. Bought at premium or bought at discount. So anyway, so we get this nice formula. So then if I this also you can think about, like, let's draw timeline and think about it a bit in more detail. So here is 0, here is T minus 1, here is T, this is N. Okay. So here you can calculate the book value, BT minus 1. That would be the future coupon plus C. Okay. So you can see that if you bring it here, okay, because it's going to grow, I mean, you can easily prove that BT is 1 plus J time BT minus 1 minus CG. Okay. So what is CG? CG is actually FR. Um, so, so this would be basically, remember how you define G? G is basically FR over C. So if you multiply CG, that is basically FR. So this is actually FR in a disguised way. Okay. So 1 plus J, so this one is growing into here, then you remove that moment coupon because it's already paid. So then you get the present value of all future payments. So this is what? This is basically present value of all future payment, including coupon payment at time t. Okay, but BT is what? BT is present value of all future payment, excluding. You have to excluding payment at time t. So this one including payment at time t. So we have removed the then the payment at time t. So this is what? This is payment at time t. So so that would give you the this one. So you can't just leave it here. So you remove the payment at time t, which is basically coupon payment or CG or FR. So so you get this transform. In particular, at time 0, B naught equal P, which is price paid by buyer. And then at the time N, it is going to be C. Okay. So you are only removing the FR. So if I enter this one, like if I enter this formula at the time N, you end up with C. So this is basically a redemption amount. The values B0, B1, B2, Bn are the values kept on accounting books. And they give smooth transition from the purchase price B0 to the redemption amount Bn. So you can see right away how they are going. So you start with P and then you are going to end up with N. So you have in middle B1, B2, all the way up to Bn. So basically, so now we will go to that graph, but you can see either P goes from P to C, like increasing, or P to C decreasing, depending on whether P is more than C or less than C. Okay, and depending on one of these, we will see the two different type of graphs. The book value do not take into account market force, and BT therefore usually not equal to the price for which you can sell the bond at time t. Now that's you have to be careful. Okay, all of these we are doing under the yield rate which we want. It's not really the price you can sell. Now remember, when you buy bond, okay, you have two options. One is keep the bond until mature. Okay, that's one thing you can do. Then the other one is sell the bond in a secondary market. So, so sometimes selling the bond rather than keeping it until mature is more profitable. For example, if market want more safer instrument, then the demand for bond may go up. So that means the old issue bonds, like the ones already in the market, their price may go up. So then maybe selling it is more profitable than the keeping it until mature. Because if you keep it until mature, then you will receive only the coupon amount and the redemption amount. But if the market demand goes up, then they may then they are, so it's basically supply and demand. So if there's not enough bonds, then of course bond price is going to go up, and then you can sell it at higher price than you maybe even than your purchase price. So it's depend on depend on the situation. Okay? So anyway, the BT is not the price which you can sell. Okay? The price you can sell decided by the market, not by the book price. This is just for the accounting purpose. Okay? So just keep that in mind. Okay, so now let's draw the timeline again. So here is 0. This is the book value. Okay. So here you have B0, and then this is T, this is BT, and then this is N, that's BN. This is C, B0 is actually a price. Okay. So when you have this T minus 1, then the interest, remember the loan, how you calculate the interest? You multiply this by the interest rate, no? So basically interest, which you use the IT, is the rate J time BT minus 1. Okay. Now this one we can simplify because we know that the BT minus 1 is CG minus C time J minus G minus J V N minus T plus 1. Okay. So we can use that formula. This is actually another formula we learned in the bond pricing. Let me go and show you. At very beginning, we learn about this formula. So basically, actually, you can use this or this one. You really want, we can actually derive it if you. So the price, so maybe let's talk about this a little bit. So maybe the formula wise. So you have J. What is BT minus 1? We have the formula here, no? So BT minus 1 is going to be this one. Is basically C time J minus G minus J A N minus T T minus 1, so N minus T plus 1 J then plus C time B N minus T. Plus C. So, plus C. Okay, so let's try to simplify this. So this one we have C G minus J. This one I can write what? 1 minus V to the N minus T plus 1 over J. That's the formula for the annuity immediate plus C. So let's again multiply. So if I multiply this one, I will get J C time. I have to put parentheses, bigger parentheses. So I'm multiplying this term, this entire term, and then this one. C time J. Okay, so this J to this J cancel out. So what do you get? So I would get C time G minus J minus C time G minus J V to the N minus T plus 1 plus Cj. So you can see that's this one. If I expand, I would have Cg minus Cj. This to cancel out, and I would get this nice formula once you take the j as common factor. I mean, we have this next one. This is basically IT, which obtain using this formula. Okay. So that would be the interest. Now remember during the loan payment, we learned that payment amount should be what? The payment size should be basically IT plus PT. This is interest, this is principal amount. So we know the payment amount. Payment amount is FR. So I can use that formula and calculate the PT. So IT plus PT should be basically FR, or in other words, CG. Okay. So then from here, using this formula, I know that CG minus C time G minus J equal to, or by plus, this is basically IT part, plus PT equals CG. So now I can solve for PT, the principal amount, and you can see that's going to be basically C time G minus J Vn minus T plus 1. So it's a nice formula. Okay. So this one is interest, this one is principal amount. And when you add 1 and 2, 1 and 2, which is basically IT plus PT, as we always know, that should be equal to the payment, coupon payment. Okay, so that's what you see in this, in here. Okay, so these two forms. So this shows that coupon amount can be split into payment of interest and payment of principal. If bond sells as premium, that means G is more than J, the amount of PT is positive. Okay, so if G is more than J, that means in here, G is more than J, then of course PT is going to be positive. In this case, a part of each coupon should be compensate the investor for the premium paid, and the remainder should be viewed as interest. If bond sells at discount, that means G is more less than J, the amount of PT is negative. In this case, the coupon is not sufficient to pay all the interest due, and the balance must be borrowed. The outstanding loan balance increase. If the price of bond equals the redemption amount, then the PT equals 0. So here you can see how this is going to work. So you can see start from 0 and end at end. So in this case, actually, P is more than C. Okay, both at premium. Okay. So amortization of premium in that case. Okay. So this imply that BT form a decreasing sequence, and the process of finding the intermediate book value is called the writing down the book, because it's going down. Then the other one, remember for the amount of, when you have the discount, basically what's the amount of discount? If I come back here, I have PT, which is C time G minus J V n minus T plus 1. Now, if you bought a discount, then that means G is less than J. Bought a discount. So that means basically PT is negative. Okay. Because of that, we take the negative of that. So I will write negative PT, which is negative C times G minus J, because we need the positive values to talk about them. That make this graph. So can see that then it's look like this. So this amount then we call as the amount for accumulation of discount in the teeth coupon. And this sequence form an increase in sequence since BT, which is BT minus 1 minus BT, imply BT form an increase too. So this one called the writing up the bond. So in this case, price is less than C, redemption amount, you start lower and go all the way up. Okay, so here you can see example of amortization schedule. 1,000 bond redeemable at par on December 1, 1998 with 9% coupon paid semi-annually. The bond is bought on June 1st, 1996. Find the purchase price and construct bond amortization schedule if the desired yield is 8%. Compound semi-annually. So first thing, let's try to find the price. Price mean what? Price mean basically be 0. Okay, so 0. This is December 1st, 1998. June 1st, 1996. And then go all the way up to December 1st, 1990. So that to include, you can see this is 0, 1, 2, 3, 4, 5 payments. Okay, so here we need to know the price. So price is going to be coupon amount AN J plus CVN. And the coupon amount is basically renewal at par. So it's par value bond. It's 1,000. And the coupon amount is 9% semi-annual. So it's going to be 1,000 times 9% divided by 2, which is 45. So coupon amount is 45. Okay, so so we can calculate the price. 45. The rate J, we should use 8% divided by 2. Okay, that's the yield rate. So this is 4%. Okay, so J is 8% divided by 2, which is 4%. V is 1 plus J to the power negative 1. So in this case, negative 5. Okay, so you can use a calculator. Let me use my calculator. I am putting on my, bring it here. Okay, so let's so what is refresh this. I mean, let's reset it. For some reason, it's not working. So let me use my calculator. I have it in my hand. So You use your calculator and try to get the answer. So first, let's reset the calculator. And you can see N is 5. Payments are 45. Future value is 1000. Rate is actually 4%. If we enter at 4%, then the POY and payment per year and compounding per year is 1. And then we need the present value. So compute present value. And this one give you 1022. And 26 cents. So that is the price. So that's what you see in here. Okay, so we verify that's right. So next thing we get the coupon and we need to divide. Okay, so we get the coupon amount. Coupon amount is $45, and then first the interest. Let's calculate first the principal amount because that is easier. Since P is more than price, the redemption amount, which is 1000, the principal amount is going to be positive. And PT is what? PT is basically C time G minus J with the N minus T plus 1. Okay. So in this case, what is G? G is FR divided by C. Since F and C are same, G is basically same as R. Okay, so I can just use the rate R. I mean R divided by 2. Yeah, it is just in the rate for the coupon rate per 6 months, which is 4.5%. So this would be 0.045. Okay, so C is 1000. Let's calculate the first for the first payment. C is 1000, G is 0.045, J is 4%, V is 1.04 to the negative, N is 5, T is 1 because we are calculating for first one plus 1. So when I do this calculation, let's use your calculator and see what would be the P1. So 0.045 minus 0.04 time 1000 time 1.04 to the power negative 5 minus 1 is 4, 4 plus 1. So I would get 4.1096. So which is approximated as 4.11 in here. So this one is amortization of premium. Why? Because price is more than C. So this one implies amortization of premium. Okay, because P minus C is positive. Okay, so if P1 is 4.11, then we can calculate IT using this nice relationship. Okay, so basically I1 plus 4.11 should be equal to 45. So 45 minus this value, I would get 40.89036447. So you can continue this calculation, and then at the end you can see it would be book value become 1000, and then total interest earned would be 202. It is different from the total coupon payment. So then the tax should be on this amount, okay? And then the amortization of premium is $22.25. If you graph it, you would see that this look like this. Okay. So you can start from time 0, which is basically 1022 and 26 cents. And then this is time 5. This would be $1,000. And then you have all these book value in the middle. Okay. So this is the same one, another similar type question, but in this case, it's discount. So try that, and then you can see that the amounts are negative. Okay. So now you will have to pay tax on more than what you received as coupon payment. Your total coupon payment is 225, but your tax is going to be based on 246 and 65 cents. So this one is very high. Why? Because the premium is less. So you bought a $1,000 redemption amount bond at less than that. So you paid price less than C. Okay. Try to recreate that table. Okay, so in here you will see a problem which says bill by 10-year 1,000 par value bond with some coupon period annual rate of 6%. The price of an annual nominal yield of 6%. Construct the amortization schedule. So I'm going to leave it for you. So again, try and ask me if you have a question. The amortization schedule means basically you are creating this table. Okay, this table. So you would create a date. Instead of date, you have like actually the time or the payment number. Then you have the coupon. Then you have the interest. Then you have the accumulation of premium or discount, depending on whether you bought at premium or discount. Then the book value. Okay, so you create that table for this. Okay, so now let's see what kind of question they would ask in exam. So this one says a 40-year bond is purchased at a discount. So what that mean? Let's think about that line. So that means basically price is less than redemption amount. Okay. And that P. The bond pays annual coupons. So this one is annual coupon. The amount for accumulation of discount in the 15th coupon is that. So basically, so it's saying amount for accumulation of discount in the 15th coupon is 194. Okay, so that means basically PT, which is C time G minus J, negative PT. Okay, so you have to put negative sign. C time G minus J, V n minus T plus 1. Okay, so this is amount of accumulation of discount. Okay. So 15 coupon. Okay, so S right P50. V minus J, V N is 40 and these are annual coupons. Okay, so 40 minus 15 plus 1. And that's going to be what? 194.82. The next one says the amount for accumulation or discount the 20th coupon. So the reason I'm putting negative sign, if you look at this discount, this schedule amount for accumulation or discount, you can see this negative sign. Unless you put another negative sign in front of that, you will get negative value. Okay. So that's why you will see this negative sign. This one would be 306.69. Now, when you divide 1 by 2, what do you get? You would get V, this one 40 minus 15, which is 25 plus 26. This one 40 minus 20, which is 20 plus 1, 21. So that would give us V5 equals S. Here's our calculator, 194.82 divided by 306.69. So I would get 0.635234 and that would tell me V is basically to the power 1 divided by 5, which is 0.91324391. So V is actually 1 plus j to the power -1. Now what is that? Then so then I can take the j actually. So from here I can see 1 plus j equal inverse of this number, which is 1.09499771. So j equal yeah, let me write this. So j equals 0.09499771. Okay, so calculate the amount of discount in the purchase price of this bond. So how do you, so in the purchase price, okay. So we use the premium discount formula, and then that one says what? P minus C equals C time G minus J A N J. Okay, that is the premium discount formula. Okay, so if I go back here. So premium discount formula says discount is C minus P, premium is P minus C, which is C times G minus J A N J. Okay, so we are using this formula. Okay. Or if this one, okay, one of them. The same thing is depend on the which one is bigger, premium or discount, premium or relation amount. Okay. So let's calculate this one. So I need C time G minus J. What is A and J? That's 1 minus Vn over J. Okay. So I need this quantity and I need Vn, I need J. V and J I already have, but I need C times G minus J. So let's go to equation 1. From there, I know that one. I know that C, negative C time G minus J V to the 26 equal 194.84. That would say negative C time J is going to be 194.82 divided by V to the 26. We already know this one. So if I use that to the power 26, 0.91324391 to the 26. So let's see what we get. Divide by 0.91 to the power 26. So I would get 2062 and 42. Please check it. In case I made a mistake, you can let me know. Okay, so I will write that number here. So it's 2062.42011. 1 minus, remember we are doing for the at the very beginning, okay, at the purchase price. So n should be 40. So V to the 40 over J. Okay, so this one time 1 minus V is 0.91 to the 40. Then divide by J. J is 0.009. Yeah, I'm getting really big number. So I would get 21,134 and 588,689. Check that again in case um, whether we made a yes, look like right, but again, check again in case if I made a mistake. You can let me know. Okay, so so I get really big number. Okay, so I think that's right. You check it again. Okay, let's go to the next problem. This one says what? This one says an investor pays $962.92 for 10-year bond with an annual coupon rate of 8% paid semi-annually. The annual nominal yield rate is 10%, convertible semi-annually. Calculate the discount of this purchase. Okay, so we need to know the discount. So basically, C is bigger than P. So C minus P is then C times J minus G, A and J. That's the formula. So price is given. So this is basically discount amount. And the price is given as $962.92. Um, and then we need to know this quantity. Okay. Okay, so let's see what should be the best approach we can use in this kind of situation. So I have the annual nominal yield rate, 10% annual yield. So J is basically 10% divided by 2, which is 5. Um, G, which is FR divided by C, annual coupon rate is 8%. So here's semi-annually, so it's 4%. So let's try to calculate this quantity and see what do we get. So what would be the so I have P, which is FR A N J plus CN. That's another formula we can use. I think without redemption amount, this problem may be not easily solvable. Let's come back to this problem later. Maybe I'm missing something here. Because we have only price. Oh, actually, we can solve for the C right away. But do that, you need to assume whether face value and the redemption amount are same or no. So in this problem, if we assume face value is same as redemption amount, then you can really solve it. Okay, so let me do this way. Assume F equals C. Okay. So if F equals C, then G become R. Okay. So in that case, I can solve for F using this formula. Okay, so price is $962.92. F face value is there, but then the coupon rate is going to be 4%. AN is going to be actually there is a 10-year bond with 20 coupons because semi-annual coupons. So A20. The rate we should use is 10% converted semi-annual, so which is 5%. Then the F and C are same. Okay. So if we do that, then So I can take, this would be F. So F and F become common factor. So that's why I have F outside here. Then here again, I have V to the 20. V is 1.05 to the power negative 1. So now I can solve for F right away. A20, if I use the formula, 1 minus V to the 20 over J is 5%. Plus this V is again 1.05 to the negative 20. Okay. So I can solve this side and I can find the phase value. So 1 minus 1.05 to the power negative 20 divide by 0.05, then time 0.04 plus 1.05 to the power negative 20. So this one become 0.875377,897. Then the face value become what? 962 cents divided by that number, which is 1100. 0.004927. So now you can easily get the discount, which is C minus P, which is C equal F. So F minus P, which is 1100 minus 962.92, which is 137. Now, this can be done only under this assumption. If you assume face value is not same as C, then you cannot do this problem. Then you need more information because then you have only one equation with two unknown. But if you assume face value equal redemption amount, then yes, you can do this problem. So this is actually exam FM question. So I think you have to assume F equals C if C is, in some questions. Okay, so you have to be careful which question you need to assume. Sometimes F is not C, but the C can be found using the information given. Okay, if C cannot find using given information. So this one, $10,000 par value, 10-year bond with 8% annual coupon is bought at premium to yield an annual effective rate of 6%. Calculate the interest portion of the 7th coupon. So how do you calculate the interest portion of the 7th coupon? Let's calculate first the premium. This would be what? This would be C time G minus J, V N minus T plus 1. C time G minus J, V. It's N is annual coupon bond, so N is then 10. This is 7th coupon, so T is 7. Okay. So now what do we need? We need it's a par value 10 par value bond. So C is 1000. So this one, okay. Then G is going to be coupon amount because F and C are same, which is R. In this case, 8%. So this one is okay. Then J is given as 6%. Again, effective rate. Then the V is basically 1 plus J to the power negative 1. Okay, so everything is there. Then yeah, so we can calculate first the principal portion, then you can calculate the interest. So you know that IT plus PT equal coupon amount. In this case, coupon amount is 10,000 times 8%, which is 800. So you can do that. Okay, so I'm going to leave this other exam FM question for you to try. Try those and let me know what you think. Whether if you cannot do it, always contact me. Okay. Thank you. Again, see you in the next section.